Hi everybody. We're going to take a look at the page 11 problems in the workbook, and I'm going to go through these quickly. You can pause to take a look at the results or maybe slow me down. So the first part is we have to use some of the basics about triangles. So for example, in a triangle, the three angles have to add up to 180 degrees. So the missing angle at the bottom of this triangle, since I have a 90 and a 30, is going to be 60 degrees. So that's the sum of three angles in a triangle. Next, I want to look at the measure of this angle on the outside of the triangle, which is going to be supplementary to the 60-degree angle. The two angles together form a 180-degree straight angle. And so the missing part to make that equal to 180 degrees is 120. So that's two of the basics, supplementary angles and the sum of angles in a triangle. So moving on to letter B, working backwards, I say, well, I can't figure out this angle on the outside because I don't know what the supplementary partner is, which is this dot up at angle MLN. So I know these three angles, 105 plus 1 plus 60, and that third angle have to add up to 180, so I can subtract them from 180 to give me the missing angle, which in this case 165 subtracted from 180 is 15 degrees. And that's what the dot is. Don't have room to label it inside, so 15 degrees on the inside of that corner. And its supplementary partner, angle PLN, is going to add up to 180, so it's going to be 165 degrees. I guess I should be writing my answers down here at the bottom. So you see, you don't get the angles directly. You usually have to work a little bit to get to them. However, we have angle PSR here right at the beginning that is a supplementary partner to 60. So that would be 120 degrees. That one should have been pretty straightforward. But to find the exterior angle RTW, I need to know this third angle, which looks like 90 degrees, but it's not. The dot at RTS is going to bring that up to 180 degree triple. And so that's going to have to be just a little bit less than 90. It's going to be 87 degrees. And you can double check that 60 plus 33 plus 87 is equal to 180. And now, adding that to its supplementary partner, they have to make up 180 degrees. So this must be 93 degrees on the outside of this triangle. And the last one on this row has the idea of complementary pairs. So if I'm going to go for ACF right at the beginning, I'm going to say these two angles are a complementary pair. Complementary adds up to 90 degrees. And so your missing angle is going to be 45 degrees for angle ACF. A little bit more complicated to find out the angle at A, because before we can do it, I need to know the other angle in this triangle at angle ABC, which is going to be a total of 180 for these two, so that'll be 60. And so the three angles together have to add up to 180 degrees. 60 plus 45 is equal to 105. And so the missing angle must be 75 degrees at the top, or at least the bottom, I should say, 75 degrees for angle BAC. Now let me pause for a moment to move to the next section. I'm not going to take a long time on this section. It's important to understand that there are four acute angles that are all going to be equal to 72 degrees. The vertically opposite between the 72 and the angle at the top there forms a bow tie. That's where they're equal. So this must be 72. Angle B must also be 72. That's because of the Z, which I'll draw in here with the highlighter, 72 degrees for that Z. So angle B is 72 degrees, and so also is the angle vertically opposite from B, the 72 here and 72 here degrees. And the other four angles are all going to be equal, and they're going to be all obtuse angles that are the supplement to the 72 degrees, meaning it's going to be 108. And as I said a couple of seconds ago, these four obtuse angles are all congruent. 108 is going to match with A, because there's my congruent pair, forming the bow tie, vertically opposite. I do have another Z in this diagram that I could use, kind of a stretched out version of it, because it's going in the other direction. And so that's why A and C must match, because they're both tucked inside that corner of the Z. So A and C are both going to be 108 degrees, and the fourth one also. So the next two examples are pretty much the same. So let me just sort of point them out here. 43 is going to match B. B is going to be 43 degrees. E and G are also going to be 43 degrees. The supplement to 43 degrees, I'll put it up at the top here with A, is going to be 137 degrees. And those four obtuse angles, 137, 137, 137, and 137, for all four of those obtuse. As I've said a couple of times, this is like train tracks with a road cutting across, and it forms four angles, two intersections, four angles that are going to be acute and four angles that are going to be obtuse, and they're going to match up in pairs. So looking at letter C, this 130 degrees here is going to match the 130 degrees there. It's going to match the 130 degrees at B and the 130 degrees across from the B. The acute angle A, which is the supplement for 130, means it has to be another 50 degrees to add up to 180. So that one is going to be, 50 degrees. This one inside here is going to be 50 degrees, 50 degrees up here and at the end. Okay, hopefully that helps you. Moving on. A and B and number 3 have a couple of extra little details that we have to pay attention to. First of all, this time the line crossing the parallel lines, and I'll call that AB to give it a name, is perpendicular to both of the parallel lines, which means this 90 degrees we see at the corner is also going to be 90 degrees around all four of those angles. It's also going to be 90 degrees around all four of these angles at the top. So right away, measure of B must be 90 degrees, which also means that inside of the triangle, this is 90-degree corner, making this triangle a 54, 90, and the remaining angle has to bring it to a total of 180. So that's going to be 26 degrees. 36 degrees, whoops, because 54 and 36 are going to add up to 90. Now that I know that 36-degree angle is here, then I can figure out its complementary partner, C, which is going to be 54 degrees. Now you could have also seen that from this concept about the Z property, because if you look at the Z that's formed from these parallel lines, you can see that C, angle C, must match the 54 up on top. Moving along, angle A and the 54 degrees are going to be supplementary. Therefore, angle A brings 54 up to 180, which is 126 degrees. It's kind of puzzles, and you don't necessarily have to find these angle measures in alphabetical order. So starting off with question B, I'm going to break the rule here and just say I'm going to do it in alphabetical order because A is the supplement to 119 degrees, making this 61 degrees. And the Z that we can see, and remember what the Z is all about. It's a pair of parallel lines and a line cutting between them. The top and the bottom of the Z are parallel pairs, and the tucked inside the corners, as I refer to it, are going to be congruent. So C must also be 61 degrees. And the supplement to this 61 is angle D, which is, surprise, surprise, 119 degrees, just like over here, right? So what do I have left? Oh yeah, angle B. Same thing as I did in question A. I got a 90-degree corner here, so I'm going to have a 90-degree corner up there. A perpendicular to one of the parallel lines must also be perpendicular to the other parallel line, and so angle B is equal to 90 degrees. In this question, we have a whole bunch of the ideas we've talked about. We've got parallel lines, we have sum of angles in a triangle, we have vertically opposite angles. So the first thing I'm going to start off is actually an angle that's not even asked for, just for the fun of it, the third angle in this triangle, so that all three angles add up to 180 degrees. 115 plus 35 is 150, so this one here must be 30 degrees. Now you think that's not going to be very useful, but actually I can see that with this parallel line PS, which is parallel to the part QM or MN, there's a Z there. And so, hey, what do we know? It's even looking for angle Z, which is going to be 30 degrees. Moving to the next part of this, well, let's look at the 35 and the angle X. Do you see the bow tie there? Those two angles are going to match. So X is equal to 35 degrees. Now, as far as angle Y goes, going to have to just recognize that they have another bow tie. Let me get rid of these for a second because they can get you a little bit distracted. This angle Y and this angle Z are vertically opposite, 30 degrees each. Not too bad, I hope. If you were looking for this other angle, which isn't actually asked for, you might detect right away that it's 115 degrees because of another blue Z that's floating around. Let's get the blue one here. Or you can say it's part of this supplementary triple that would go across with the 30 degrees and the 35 degrees. If you understood those previous questions, then these ones on page 12 should not be too much of a problem. We have a whole circle of angles here that are added to 360, but it's better to look at the 90-degree pairs and the 180-degree pairs. A quick word about question B is that we have vertically opposite angles, which may not be so obvious. The 78 and the C are going to have to match. We also have this pair that adds up to 90 degrees in this corner where the 78 degrees is, so that angle A is going to have to be 12 degrees to bring that up to a 90, right? A is talking about that little corner sharp angle. And angle B would be supplementary to angle C, working that out. Question C, we have these four corners. Like I said, you could be looking at the 360, but it's better to be looking at the pairs that add up to 180. It's a lot easier for the calculations, all right? There's no parallel lines in here, but there's lots of work going on, and there's a triangle that has a total of 180 degrees when you're working that out. And we can find out A because it's going to be 42, and we can find out C because it's the supplement to 110. Have some fun with the parallel lines in letter D, E, and F. And this question here, same kind of setup, lots of examples, but just work your way out from the 25 and the 90 through the rest of the problem. Good luck working with this, and hopefully you're going to get the hang of it. Thanks.